Hello, my name is Alex Slonimer. The focus of this study is the classification of fish and bubbles in 1 hour multi-frequency echograms. And these were sampled with at 4 frequencies, as you can see in the top figure in panel 4, where depth is the y-axis and time is the x-axis. And so the species of interest are herring and salmon, and classifying these is challenging because they're of similar size and they both have swim bladders. And this results in them having similar acoustic scattering signatures. However, they have very different schooling behaviors, and that can be used to tell them apart. But salmon are often confused with air bubbles because they look quite similar due to being both located near the surface and being sparsely distributed. But they are quite different in their acoustic response across frequencies, so this can be used to differentiate them. Doing this, telling them all apart, though, manually is very challenging and tedious. So in this study, we've used CNNs to do the classification, and these are great because they can classify the images based on both the morphological features and the relationships between the frequency channels. And a UNet is used because it's able to perform precise pixel level classification. To effectively train the model with a small data set, the echograms are divided into square tiles. And unlike a photograph, the position in an echogram contains really important information regarding the environment, which has an influence on the species behavior. So to retain this non-visual information when the tiles are divided, simulated channels for water depth and sunlight have been introduced. So after training, the UNet is able to accurately classify all 3 classes. And we can see examples of this in the white bounding boxes in the central figure. Salmon and bubbles are accurately differentiated even when bounding one another right adjacent to each other. Salmon and herring are very rarely misidentified as the other species. Only 2% of the time, and herring are never misidentified as bubbles. Overall, on a test set of 31 echograms, the UNet was able to achieve F1 scores of 86% for bubbles, 87% for salmon, and 93% for herring. So this work has demonstrated that UNets are able to be trained with very little training data, and that the pixel level classification of echograms is efficient and very accurate.